All right, let's talk about a quick example on particle motion. We are given that this particle moves and the position of the particle at any time t in seconds is given by the equation t squared minus 4t plus 3. So remember, particle motion, you got a line, it starts at some time t. And in this case, it actually starts at time t equals 0. And that's normal for these particle motion problems. So displacement during the first 2 seconds. First thing to remember is that displacement is how far it's traveled, not where it is. So you got to be a little bit careful there. Displacement will be the position at time 2 minus the initial position. And this is a mistake that people make on a regular basis, is they forget to subtract that initial position. So doing some quick calculations, S of 2 minus S of 0, we get that this is equal to -4 meters, which means that it's actually moved backwards. It's moved to the left. So its initial velocity is in fact in that direction. All right, average velocity. Well, average velocity, change in position over change in time. So that's going to be S of 4 minus S of 0. Again, remember, change in position, the displacement, not the position at time 4, divided by the 4-second interval. And what we actually get is that this is 3 minus 3 divided by 4, which is 0 meters per second. So after 4 seconds, it's back where it started. So instantaneous velocity, now here's what we know is that instantaneous velocity is the derivative of the position. So be watching for these buzzwords. Instantaneously, or instantaneous is derivative. Average is just a difference quotient. Okay. And doing some quick taking derivatives using rules, we get that velocity is equal to 2t minus 4. So the instantaneous velocity is 8 minus 4, which is 4 meters per second. Notice that this is moving to the right. All right, worth keeping in mind. All right, the acceleration of the particle at any time t. Whoops, I meant to drag that up, not to scribble all over it. Acceleration is the derivative of velocity, which is the second derivative of position. And so that's 2, and that's a constant. And notice again, this is in a positive direction. So this particle is being accelerated to the right at all times, even though it appeared to have been moving to the left initially. Describe the motion of the particle. At what values of t does the particle change direction? Well, change direction requires 1, that the velocity be equal to 0, and 2, it requires that it change sign. So there are 2 requirements. It has to have a velocity of 0 and it has to change sign. So what I like to do, and we're going to be doing this quite a bit, is make a little bar graph where we find out when is the velocity equal to 0, and that will allow us to then check on either side. So velocity equals 0, v of t equal to 0. That means that 2t minus 4 is equal to 0, which means that t is equal to 2. So this is at 2 seconds. At 2 seconds, velocity is equal to 0. So now what we need to do is just quick check on either side. What's velocity at 0 seconds? Well, 2 times 0 minus 4 is negative. I don't actually even need to put a number in there. I just know that it is negative. And what's my velocity at some positive number? Well, I'll go ahead and plug in 4. 2 times 4 is 8, minus 4 is positive. Again, I don't have to plug in any numbers. There's only one time when velocity is equal to 0. And so if it went from negative to positive, that's the only time that it changed direction. So what's the motion of the particle starting at 3 meters, moving left for first 2 seconds, then stops and moves right. That's the description of the motion of the particle. Because from then on, because acceleration is moving to the right, it's always going to be just getting faster and faster and faster to the right. Okay, good. Velocity and particle motion.